Section 3.6, one-to-one functions, inverse functions. So in this section we're going to talk about one-to-one function. We try to understand the definition of one-to-one function, and then by using horizontal line test we can find out either a given graph is a graph of one-to-one function or not. And then after that we're going to see how to find inverse function, and then how to plot a graph of an inverse function. So this is the basic definition. A function f is one-to-one if for any values a not equal to b in the domain of f, the value of the function at a and the value of the function at b should not be equal in the range of f. So the meaning is, let's say here is the domain, this is the domain of function, and this is the range of the function. So let's say there are two values a and b and they are not equal, and a function f is called one-to-one if the value f of a and then value f of b, they are also not equal. So two unequal input give you the two unequal output. Similarly, two unequal output is only possible if the inputs are unequal. Okay, so that's called one-to-one. So there should be one-to-one correspondent between the input and output value. There should be only one line coming from domain to the range from each input, for each input. Okay, there is an alternate definition of one-to-one function. A function is one-to-one if for any two range value, meaning the value in the domain, if they are equal. That's only possible if the inputs value u and v are equal. So these are the graph in two graphs we have given. First graph is a graph of one-to-one function, but the second one is not. So as you can see that if you pick any two values on the x-axis like a and b, then the value of the function at a and the value of the function at b, this would be unequal. Two unequal value on the x-axis gives you two unequal value on the y-axis. But here in this graph, as you can see that a and b are two unequal value. A and b are not equal, but their corresponding value, the value of the function which is g of a and g of b, they are equal. That means it's not a one-to-one function. So if you have a graph of a function, then to find out either that graph represents a one-to-one function or not, we have horizontal line test. This test says if every horizontal line intersects the graph of a function at most once, then f is one-to-one. So for example, there are two graphs here. The first graph, even you draw infinite horizontal line through this graph, there is no way that any horizontal line will intersect more than once on this graph. So that means this graph passes the horizontal line test. So that means this is a one-to-one function. But in this second graph, as you can see that you will be able to find out more than one line which intersect more than one point. So that means this is not one-to-one function. So the first one is one-to-one, but the second one is not. One example. So just find out by using that horizontal line test which one is one-to-one and which one is not. Okay, for the first one, if you draw one horizontal line, you can see that there are 2 points. This horizontal line is intersecting with the graph. So we use the definition, but no matter how many horizontal line you draw for the second line, no horizontal line will intersect this graph more than once. So using the definition, we can say that the first one is not one-to-one, but the second one is one-to-one function. Now it's a time to define inverse function. Inverse function is basically it's a reverse function. Let's say you have one-to-one function, and remember inverse function only possible for one-to-one function. So let's say you have a function f which is one-to-one, and the domain of the function f is a. So there is a function f which is one-to-one, there is a domain a and then range b of that function. This is one-to-one, that must have property one-to-one, it must be one-to-one function, and a is the domain and b is the range. Then going back, reverse process, reverse of this function is denoted by f to the power -1, which is just a notation. So don't be confused with this as a f to the power -1. It's just a notation for inverse of this function or reverse of this function. So the meaning is, let's say there is a, the value of the function at a is f of a, and if you try to, let's say that's b, if you try to go back and try to find out the reverse of b, then that should be a. So the reverse or inverse of b is a, because the value of the function at a is b. So inverse means reverse, and that is only possible for one-to-one function. So let f be a one-to-one function with domain a and range b, then f inverse, that's how you read f inverse, is the inverse function of f with domain b. Now for going back process, b would be the domain for that function and a would be the range, okay, which is opposite for the function f. So then f inverse is the inverse function of f with domain b and range a. Furthermore, if f of a equal b, then f inverse b equal a. Okay, so f is the function going from a to b, and f inverse is going back process. So the first one is the domain for f, which is the range for f inverse. So remember, that's the relation between f and f inverse. Now if you have given two function and if you try to find out either they are inverse of each other or not, then you can use this property which says, if you are trying to find the composition of f and f inverse from any order, that must be x itself. So to find out two function, either these two function are inverse or inverse of each other or not, you always find the composition of these two function from both direction, and then that should give you x. you know so that's the test we can use to find out either given functions are inverse of each other or not. So for example, let's say f of x and g of x are the two function, and we need to find out either they are inverse of each other or not. So remember, to be inverse of each other, f composite g should be x. Similarly, g composite of f should be x. From both sides, the output should be x. So let's try to find out f composite gx, which is actually the value of the function f at g of x, which is basically wherever you see x in the function f, just replace that x by g of x. So I'm going to use this one. So this x is replaced by g of x, so it would be g of x over 2 times g of x plus 3. And now finally replace the value of g of x here, which is 3x over 1 minus 2x over 2 times 3x over 1 minus 2x plus 3. Now we need to simplify this. So on the numerator there is just one term, but on the denominator there are two terms. So you can just add by making the same denominator here. So for that, I'm going to multiply this 3 by 1 minus 2x, the numerator and denominator. I can do that. Okay, so now after this, as you can see that there is a 3x over 1 minus 2x on the top, and because they have the same denominator 1 minus 2x, I'm going to write down 1 minus 2x on the bottom. Now 3 times 2 is 6x plus 3 times 1 is 3 minus 3 times 2 is 6x. So I can cancel this positive 6x and negative 6x, and similarly this 1 minus 2x here and this 1 minus 2x here can be cancelled out. So the leftover thing is 3x from the top part and then 3 on the bottom part. So if you just cancel this 3 and 3, that will give you x. So from one side, we found that's x. We have to do the same thing from other side. Okay, so from one side we already found that f composite gx equal x. Now we need to find out g composite f x, which is the value of the second function when x is replaced by f of x. So just go here, replace this x by f of x, and finally plug the value of f of x, which is x over 2x plus 3, and 1 minus 2 times x over 2x plus 3. We can do the same thing like we did here. We can make the same denominator um, on the denominator part. As you can see that there is a 1 over 1. We can multiply the top part and bottom part by 2x plus 3. Here it's a 2x plus 3 over 2x plus 3. We can do that to make the same denominator. By doing that, on the top you have 3x over 2x plus 3, and on the bottom there is a 2x plus 3 minus 2x over 2x plus 3. We can cancel this 2x plus 3 and 2x plus 3. We can cancel this positive and negative 2x, and on the top part you are going to see 3x. On the bottom part there is a 3, so after cancellation it will give you x. So from both direction, either you find f composite g or g composite f, both of them are giving you x as an output. That's why these two functions f and g are inverse of each other. Okay, now if we would like to plot the graph of inverse function by looking the graph of a function, then that is possible. We just have to switch x and y coordinate. Sketching the graphs of inverse function. Find the graph of the inverse of a one-to-one function by interchanging the coordinate of each order pair that lies on the graph of f. The graph of the inverse is a reflection of the graph of the function about the line y equal to x. So for example, let's say this is a graph you have given, and we know that this is one-to-one function because no horizontal intersect this graph more than once. So let's say this is your 0 1. So to find the graph of inverse of this function, you just have to switch x and y coordinate. So switch means this AB becomes BA, this 0 1 becomes 1 0. You are just switching x and y coordinate, and finally after switching all these x and y coordinate and plotting them, you will be able to see this graph, which is, if this is the graph of f of x, then this is the graph of inverse of f of x. So that means f inverse of x. So they are actually, mirror image if you place the mirror on y equal to x line. One more example, as you can see that the red one is a graph of cube root function and the blue one is graph of cube function. They are actually inverse of each other, and you can find the graph by just switching the x and y coordinate. One more example, this blue one is the graph of x squared plus 1, and this is the graph, and from the graph you can see that the domain of this function is from negative infinity to 0. The range is from 1 to infinity, and then if you just switch x and y coordinate, this is the graph you are going to get, which is the graph of f inverse. And by looking this graph, as you can see that the domain would be 1 to infinity, and then range would be negative infinity to 0. So as you see here, they are just reverse of each other. Now sometime we need to find out inverse of a given function. So if we have to find the inverse of a given function, first of all write down your function f of x to y. So replace that function by y. That's the first step. The second step is, after that, interchange x and y. And then a third step is now solve for y. And then finally that y would be your inverse of the original function. One example, let's say this is the function. We know that this is one-to-one function, so we would like to find out the inverse of this function. So first of all write down this function, that's the first step, as y equal 2x over 1 minus 5x. So that's the first step, change f of x to the y. Second step is interchange x and y, meaning wherever you see x, replace that by y, wherever you see y, replace that by x. Okay, third step is, now in this equation solve for y. So solve for y. For solving for y, so first of all what we can do is we can just multiply both sides by 1 minus 5y. So that is x times 1 minus 5y, and then 2 times y. And then after that distribute this x, that is x minus 5 times xy equal to y. Because we are solving for y, so we bring all the terms with y on the one side. So here I'm going to just add 5xy both sides. By doing that, on the left side I have x, and on the right side our goal is to find the y. So this is actually 2y plus 5xy. I'm going to factor out y, and it will be 2 plus 5x. Now that is the step 3 would be solve for y. So meaning just find out the y. So to find out the y, just divide both sides by 2 plus 5x. So that will give us y equal x over 2 plus 5x. Okay, so that is our step 3, solve for y. That y would be our inverse of the given function. So the inverse of given function, that's step 4. Inverse of given function is x over 2 plus 5x. Okay, so by looking this function f of x and f inverse of x, as you can see that you can find out the domain and range for this function. The domain of this function is all real number except this 1 minus 5x equal to 0, which means x is not equal to 1 over 5. So the domain of f is all real number except 1 over 5. That is how you write it, all real number except 1 over 5. The range is, as you can see that uh, the domain of f is this one. And similarly, before finding the range of f, we are going to find the domain of f inverse. This is f inverse. So the domain of f inverse is all real number except this 5x plus 2 cannot be 0. So solve for 0 here. So x is negative 2 over 5. Except x equal negative 2 over 5. So the domain of f inverse is everything except negative 2 over 5. So now, because inverse meaning just a switch, the domain of f becomes range of f inverse, and then domain of f inverse becomes range of f. You see that these two are equal and these two are equal. It's just switching. Okay, so that's section 3.6, one-to-one function and inverse function.